Okay guys, so I'm just going to try to explain how med math works in my head. If it helps someone, I hope it does. We're going to skip the first question because that looks really obvious. The next question, the induction dose of rocuronium is 1.2 milligrams per kilogram and the patient weighs 80 kilograms. How many milligrams would you give? So in my head, I would first do 1 milligram per kilogram and know that we have 80 milligrams. But then if I want the 0.2, I understand that decimals and percentages are basically the same thing, so I understand I could just do 20% of 80 kilograms, which that still sounds confusing. So then if I do 10% of 80 kilograms, I know 10% of 80 is 8 because 8 times 10 is 80. So I always try to make things into tens or hundreds or thousands. Then it will make the math simpler. So I just know that I need to add plus 8 2 times, and then I would get 96. And then the next question is, rocuronium is supplied at 10 milligrams per milliliter. How many milliliters would you give? And the same way I said that I try to do everything by tens, I'd want to divide 96 by 10, and we know that there's a decimal point at the end of every number. So if you're dividing by 10, that's going to move the decimal place to the left, and then if you multiply by 10 and move it to the right, but in this situation we're dividing by 10, so it would be 9.6 milliliters. I will try to explain how my mind gets to this situation, but first I'll show you how it works so you can believe me, but then I'll show you the easier way. So when it's saying a 25 milligram of cardine is added to a 250 bag, I know that 250 milligrams, which I'm pretty sure 1 milligram of saline is 1 milliliter. So if we're assuming that, I know that 250 times 4 is 1,000. So if, I'll write that out. And then I know 25 times 4 is 100 milligrams. So basically, I would get to the point where I'm at 100 milligrams equals 100,000 micrograms. And then if I put that over 1,000 milliliters, if I cross out 3 zeros at the bottom and then cross out 3 zeros at the top, I know that I am at 100 micrograms per milliliter. But the easier way to solve this is just, if you're at a milligram to milliliter conversion, you ask yourself, how many times does that bag go into 1,000? And for this situation, it would be 4. So then I multiply this by 4, which would be 100. I'd know that I'm at 100 micrograms per milliliter, and we know that we want milligrams at the end of the situation, so then we would just have to divide that by 1,000, and then if you divide 100 by 1,000, you end up with 0.1 because you can move the decimal over 3 times, and then you're left with that number. So then for the 200 micrograms of Precedex that's diluted into 50 mil, I'll let you guys think of that for a second as I write it out. So if we have 1,000 and we want to divide it by 50, I know that that has to be 20 because I know that 100 goes into 1,000 10 times and 50 is half of 100, so that's how I think of it. I'm sure that you could do a fancy way with getting rid of the zeros, but I don't honestly know how to do that, so I'm not going to. But then we know that if we multiply 200 times 20 like we did earlier, and then I know that has to be 4,000 because I know 2 times 2 equals 4. And then all we do is just add these 3 zeros at the end. So 1, 2, 3. So we know that we are at 4,000 micrograms per milliliter, as I explained. And then it says, what is the concentration of medication per milliliter? We're at 4,000 micrograms per milliliter, but if you want to make it more fancy, we can say 4 milligrams per milliliter. Okay. So this next one actually does kind of explain it good. It says that if you're at like 3% solution, all you have to do is add a 0 at the end, and then you will get to the milligrams per milliliter of the solution. So a 3% solution is 30 milligrams per milliliter. A 0.9% solution is 9 milligrams per milliliter. So when we get to saline, we know that 0.9% saline is 9 milligrams per milliliter, which also means 9 grams per liter, because if you multiply 9 times 1,000. So this one, it says, how many milligrams are in 5 milliliters of a 4% cocaine solution? So we should know that if we're at 4%, we just add a 0. So we're at 40. And then we multiply that times 5. And then you can do 5 times 4, which is 5, 10, 15, 20, 20. And then we add one more 0, and then we're at 200. So then we know that it is 200 milligrams in the 5 milliliter solution. And then you can work backwards and figure that out as well, I'm sure, but we're not going to do that. Okay, so it looks like these questions are getting a little bit harder. This one is asking for 8 milligrams to be given of bupivacaine, but we only have a 0.5 solution, so that math can seem really intimidating in the beginning, but I try to slow down and say, what do we have? So I know that we have a 0.5%, which we have talked about equals 5 milligrams per milliliter. And that's where it might be a little bit intimidating, because we say, obviously, if we give 2 milliliters, then we have 10 milligrams, and that's not what we want. So it's somewhere in the middle, and we know it can't be 1.5, because if we did half, then we get to 7.5. The reason that 1.5 equals 7.5, though, is because if you multiply 5 times 0.1, we would know that equals 0.5. So we ask ourselves, how many times does 0.5 go into 3, which would be what we need left to get to 8. And we know that 0.5 goes into 3 6 times. So 1.6 milliliters equals 8 milligrams. The next question says your patient weighs 80 kilograms and you want to administer 1.5 micrograms per kilogram. So 1.5 times 80. We know that 40 is half of 80, so we have to do 80 plus 40, which will be 120 milligrams per kilo, or milligrams, not per kilogram. We've already done the per kilogram. And you have a 4% available, so we know that we have 40 milligrams per milliliter. How many milliliters will you give? We know that if we do 40 and then 80 and then 120, we want to give 3 milliliters. Okay, so this next problem is talking about ratio concentrations like lidocaine and local anesthetics, and it says that 1 in 1,000 means 1 gram in 1,000 milliliters. So a shortcut is to ask how many times it converts in a million, which I will explain why that works. So we know that 1 gram is equal to 1 million micrograms, because 1,000 times 1,000 is a million. And then if it's 1 million micrograms in 100,000 milliliters, then we know that we can cross out these zeros, and 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. We're left with 10 micrograms per milliliter. So then the next question says 3 milliliters of a 1 in 200,000 concentration of epinephrine. How many mics per mil? So we would understand that 200,000 has to go into 1 million 5 times, because if you cross out the zeros and everything, or you can just like ask yourself how many times 2 would go into 10, and then you can do that same calculation. We would know that if we can multiply the same thing, we'd multiply 1 times 5, we would get 5 micrograms per milliliter, and then that would lead us to believe that if we have 3 milliliters, then we have 15 mics. So for this one, I don't really know any specific tricks to how I'd think about these, but it says if you have 1 gram, 1 G of a drug, and you put it in 500 milliliters of a solution, what percent would it be? And I know that in general we're trying to find the percent by doing grams per 100 mil, so I would just think about, I would ignore the zeros honestly, and then I just know that 1 divided by 5 is equal to 0.2, so it would have to be 0.2%. And you could rework that knowing that we have 2 milligrams per milliliter, and then that would equal 2 grams per 1 liter, and then that would also equal 1 gram per 500 milliliters. I don't really have a fancy way to do that one. That's just what I would do in my head for that one. So this one's actually pretty confusing. It says what volume of 5% lidocaine should be added to 10 milliliters of normal saline to make a 2% solution. So we have 50 milligrams per milliliter, and we want to make it 20 milligrams per milliliter. And we have a 10 ml syringe, and we would know that if we have 50 milligrams per milliliter and you divide that in tenths, you have 5 milligrams for every like 0.1 of the vial you have of the milliliter. So 5 times 4 equals 20 milligrams. So we would want to put 0.4 into the 10 milliliter vial, and obviously before we do that we would want to remove 0.4 of the saline, and then we would get the 2% solution, because then we would be at 20 milligrams. I'm stupid. So this one says what volume of 5% lidocaine, we know 5% is 50 milligrams per milliliter, should be added to a 10 ml normal saline syringe to make 20 milligrams per milliliter. So we would know that we need, if we had 10 mils of empty drug and we would want 20 milligrams per milliliter total, and there's going to be 10 milliliters in the solution, we would know that we have to multiply 20 times 10, which would be 200 milligrams in this vial total. So if we have to put a 50 milligram per milliliter solution into the vial, then we would know that we need to remove 4 milliliters of the saline and then put 4 milliliters of our 5% solution into the saline, and then we would get 20 milligrams per milliliter. Question says, given a 25 milliliter vial of 1% lidocaine, so I know that 1% is 10 milligrams per milliliter, with 1 in 500,000 epinephrine, calculate the milligram of each drug. So we would know that the epinephrine is the 1 gram in 500,000, and we know that 500,000 goes into 1 million 2 times, so we would know that it would have to be 1 times 2 is obviously 2, so we would know it's 2 micrograms per milliliter. And then it just says what's the milligram of each drug. So 10 milligrams per milliliter times 25 equals 250 milligrams, and then 2 micrograms per milliliter times 25 would have to be 50. So at the end we have 50 mics of epinephrine and 250 milligrams of lidocaine. Okay, so this question looks pretty confusing at first, but when you break it down, it can be pretty simple. So we know mannitol 0.25 grams per kilogram is ordered by the neurosurgeon at incision. How many milliliters of mannitol 20% is to be infused by your patient? That is 80 kilograms. So we'd want to figure out how many milligrams or whatever we need to get to at this point. So 0.25 times 80 might seem kind of confusing in the beginning, but remember what I told you guys earlier. 10% would be 8, so then I would do 8 plus 8, which would be 20%, and then I would want half of the 10%, so then I would plus 4, so that would be 16 plus 4, and then that's 20. So we would know that we need 20 grams total. And we know that 20 grams is also 20,000 milligrams. And then we know that 20% is 200 milligrams per milliliter. And then they want to know how many milliliters we need to give. So then we can cancel out the milligrams. And then we can ask ourselves, how many times does 2 go into 20? And we know that should be 10. I canceled out too many zeros, actually. I was supposed to only cancel out 2 zeros, and I canceled out 3. So if we don't cancel out this 0 right here, we would know that how many times does 2 go into 200, and that would be 100. So then that's how many milliliters we would need.